functions. The function that models the number of births and deaths in the US. So this is the function that describes the births, and the other one is that signifies the deaths. It says write a function that models the change in US population for the year 2000 through 2009. But this is the number of the births, thousands in a thousands, and X years in after 2000. So now let's go in the A, and let's do this. A is, we already see the population change here is births minus deaths. So what we are doing here, we are creating a new function, which I would call a P of X, that signifies the population of the United States. And the population is going to be equal with the B of X, the births of the population, and minus the deaths, D of X. And now I'm taking a loss of function, numerical function, which is a B of X is a minus of 2.6x squared. Let me write minus 2.6x squared. And the other one is a plus 49x. And is the number. The constant is a plus 3994. And now is a minus D of X. So let me write here one minus in the front. And D of X is the first one is a minus 0.6. Minus 0.6 x squared. Is a plus 7x. And is a plus 2412. 2412. And now when we are subtracting everything, we find the new function that signifies the population growth of the function of the population growth of the US, and we can write this way. Minus 2.6 x squared, here negative become positive, and 2.6 minus 0.6 is a negative 2.6 x squared. Negative 2.6 x squared. And here is a negative times positive is negative 7x, 49 minus 7x is a plus 42x. And in the end, negative times positive here is negative, and now we are subtracting 3994 by 2412. And 4 minus 2 is a 2. Here is a 2. Because this is a bigger number, so it's going to be positive value. And 9 minus 1 is a 8. 9 minus 4 is a 5. And 3 minus 2 is 1. So this is a new function that describes the growth of population in the United States. Now let's go with the B. And the B, in the B says use the function from part A to find the change in US population in 2003. So we are using the same function, but because in 2003 and here 2000, let's say we write with a 0, 2001 we write with 1, 2002 with a 2, etc. But we are using just the last digit of the year. And 2003 I will write a P of 3 is equal minus 2.6x. Here is a point, so just let me make sure. 2.6x squared. This is x squared. And x is a 3 squared. Plus 42 times 3. Times 3. Plus 1, 1582. So 1582 is just a constant, so I don't have to multiply with anything. And P of 3, now we can find everything here. is going to be equal. So 2.6 times 3. So let's take a calculator, and let's calculate 2.6 times 3 squared is a 9, times 9 is going to be equal with 23.4. So it's a 23.4. But it's a negative sign here, 23.4. But because we don't have with the points here, so I'm taking it just to the closest units. 23.4 is just a 23. And a plus of 42.3, 2 times 3 is a 6. And 4 times 2, 3 times 4 is a 12. So 126. And a plus 1582. 1582. And in the end, P of 3, we can find here, is going to be equal. Already I know here minus 23, 26 minus 23 is 23, is just a 3. So here I have 103, and 103 I have here. 3 plus 2 is a 5. So we can do this quickly. And here this is a 0 plus 8 is a 8. And 1 plus 5 is a 6. So it's going to be 1,685 people, the change in the growth. But now population change here in the C are asking here, does the result in a part B overestimates or underestimates the actual population in 2003 obtained from the data? The data here in 2003 says we have a 4,090 birth. Let's say it's a 4,090 birth. And the deaths, how many deaths we have? The death says here, we have here this value. This is the birth, 4,090, and here the death is 2448. 2448. And let's calculate quickly here this value. 4090 minus 2412. We have 1678, and this is equal. Let me write in here equal sign, and just let me check quickly again. 1678. So it's 1678. Let me go to make sure. Let me do again now. 4090 minus 2412. 2448. I'm sorry, here I made a mistake. Is 1642. Okay, 1642, just for the sake of the real values. 1642. So 1642, but from the calculation what we got here, P of 3, we got it was 1,685, and according to the C, we are the function here, what we are finding with this function, it overestimates. So the number is greater, it means it overestimates, because of the actual data is 1642, but this is an overestimation. Let me write OS, overestimation.